Hello my students, how are you? Now we are going to explain the chromatography techniques for separation of some inks. I think I know that the inks consist of different dyes. Now we're going to explain the chromatography techniques. It's okay. Now we will draw a baseline with a pencil distance here about 4 centimeter apart. Yes, we make it by pencil. Only by pencil, not other materials. Okay, you can see now we put some spots like the colored pens. Yes, you can see you put the red and different colors. We put here stop another spots by green, and the third color is for example is brown. Yes, we have to put only small spot, not bigger spot. Yes, this is blue, and then yellow. We will make now yellow, and finally is black. Yes, you can see. Yes, you put it on the baseline. This is a baseline. Yes, what is the main advantage of using chromatography technique? Why is using the chromatography technique? We have to be sure if the sample is pure or not pure. This first. Yes, I know the number of components of each ink maybe consists of 1, 2 dyes or 3 dyes or three substances. Okay, we have to know that. Okay, only a small sample is required and for advantage. Now you get a beaker, yes, and put the solvent as a water. Yes, as a water. Why is water a suitable solvent? Why is water suitable solvent? Should be using the solvent that dissolve or allow dissolving the ink. Yes, our inks. It means and the color and this spot should be dissolved in the solvents or in the water. You have to be sure that. So now we put the paper chromatography inside the water, and we have to know the distance here from the surface water about 2 centimeters apart. Very important to know that. To put like this, okay, not put inside the solvent. So you can see you have to put here a lead. You can see a lead on the beaker. Why you put this lead on the surface of the beaker? Why you cover the beaker with a lead? Yes, exactly, to avoid evaporation or to minimize the evaporation of the solvent, because we sometimes using alcohol, the boiling point alcohol is very low, so they will be evaporate and more fast. So you need to make saturated and desaturated vapors inside the beaker. So you can see now by experiment the movement and of the inks, different inks, okay, through with the solvents, with the solvent, yes, of the water. Yeah, okay, you can allow, yes, you can move up until, yes, the maximum distance or movement of the inks. You can this is solvent font. This solvent very important for us, because this solvent font we have to determine it. Why? Because you need to calculate the RF for each spot here. Okay, so you have to measure the distance from the baseline to the solvent here. It means the distance covered by the solvent, say 10 centimeter, yes, for example, yes. And then we put here in the middle of the spot here, this line like this. We measure the distance for each spot, and now calculate, we divide the distance covered by the solvent. Sorry, it's the distance covered by the spot, okay, or the dye. You have 3 types of dyes here, blue and maybe I think it's yellow and purple. It's okay, so we have 3 types, so we can calculate RF for each one by dividing the distance from of each dye from the baseline. Say here is maybe 7 centimeter, and here is solvent font is 10 centimeter. So we have divided now 7 divided 10. For each, you can using the RF you can calculate the RF of all dyes in each ink, and so we can calculate the RF now. Okay. Why do we need to mark the solvent font? We have to know how we have to mark. The bright spots will be traveling up the chromatogram. This paper is called the chromatogram relative to the measured solvent font. Knowing the solvent front is important for calculation of RF values. So you need to calculate the RF value for each dye in the ink. Yes, very important. Why should the solvent front be as high as possible? Why? And to allow the solvent to move very high, to ensure the maximum separation for the spots of the dye for the accurate identification. Maybe allowed to move the solvents very high to know if the ink consists of 3 spots, 4 spots, 3 dyes for 5 dyes, and so on. Yellow ink consists of only one type of spots, yellow only, so it consists of only one spot, so it's pure sample. It's pure sample now. It consists of only yellow. And you can see the other part here. It consists of three dyes. Black ink is a mixture of 3 dyes, of which the blue dye is the most soluble in solvent. Why is most soluble? Because it moves a very large distance from the baseline, and this is insoluble. Yes, for this mixture consists of 2 dyes, but this type of the dye is insoluble and in the dye because don't migrate, don't move with the solvent, so it doesn't dissolve in the solvent. Yes, next we make another experiment, but instead of using the pencil we will use an ink. You can see using ink here, not pencil, as a baseline. Yes, using you will use here ink instead of a pencil, and we repeat the experiment. So everything it's the same, but the difference in the type of, instead of pencil we have an ink for making the baseline. Now we make an experiment again, so we have to leave as 2 centimeters apart from the surface of the solvent. You can see here the line made of ink will move with the samples or the spots. So now this is maybe inaccurate results now. Yes, so it's not correct now, okay, because maybe confused. You can't differentiate between the colors, or maybe fused together, all colors diffused together. So you can see the baseline move with us with the solvents, so it's inaccurate result now. So this type of chromatogram is inaccurate, so we can make comparison between them. This is correct chromatogram, and this is incorrect chromatograph. It's right, is it wrong? Yes. Why is the start line drawn in pencil? Why using the pencil for drawing the baseline or the start line? A pencil line is made up of graphite and insoluble, very important, in the solvent. Hence, it will not lead to an inaccurate chromatograph. Now we put all the spots now inside using the pencil. It's okay, but all spots now inside or dipped inside their solvents. So now all inks will dissolve in the solvent, so it doesn't move with the solvents up through the paper chromatography. So it gives inaccurate result now, okay, because all will dissolve now in the solvent. So now we show that the sample spots are above the solvent level. It means 2 centimeters apart, if you remember, to prevent the sample from dissolving in the solvent before it is carried out up the chromatography paper. This prevents the separation of the components of the mixture. Yes, prevent. So now we make a comparison between the 3 chromatogram now. Yes, now this is one in the first is correct, but it's error, it's incorrect, and this is one is incorrect. Thank you very much for watching. Thank you.